Hello guys, welcome on Tesla Adventures. Today in this video we are discussing the concept of distance of closest approach or the minimum distance between two moving particles. So first of all, you can see that there is a situation in which a particle A which has a velocity of 4 meters per second is moving on the x-axis towards positive x-axis, and this distance is 40 meter, and another particle B which is moving with a velocity of 3 meters per second, and it is initially at a distance of 30 meters. Now you can easily see that the time taken by the particle A to reach the origin TA is equal to the displacement upon velocity, which is 10 seconds, and the time taken by the particle B is equal to displacement 30 upon velocity is 3, which is also 10 seconds, which means that they would meet at origin after 10 seconds, and hence they will collide. So we can say that the d minimum between them will be 0. This is a simpler case, but if we solve this problem conceptually, then we should write down these velocities in vector form first of all. So first of all, VA and VB we have to write down in vector form. You can see that VA, or let us see that this distance is 30 and this is 40. So we can say that this is 30 and this is 40. Okay, now this is 40. Now we can easily say that this angle is 37 degree. Now if we write down VA, so VA would be equal to 4 I cap and VB will be equal to 3 J cap. Okay, so this is VA and this is VB. So first of all, we have to write down VAB. We have to assume anyone as observer. In this scenario, I have assumed that B is observer and A is object. So B is observing A. So B is at rest. So VAB would be VA minus VB. So VAB will be equal to VA is 4 I cap minus 3 J cap. So this is VAB. Now we have assumed that B is at rest, and if B is at rest, then we can say that this vector is going in a fourth quadrant, going towards fourth quadrant, and this vector is going like that A is at this point and this vector is going towards fourth quadrant, like that. You can see that this distance is this vector makes an angle of 37 because its y component is 3 and its x component is 4. So tan theta is equal to 3 by 4, which means that VAB vector is making an angle of 37 degree with x-axis. So it is evident that this 37 degree angle means that this vector is along the line AB only. So this is VAB, because this line AB is also making an angle of 37 degree with the x-axis, and this vector VAB is also making an angle of 37 degree with the x-axis. So it is evident that with respect to B, A is moving along this line. So if B is at rest at this position, then obviously A will collide to B, and therefore the minimum distance between them is 0, which we have already concluded. So I was just telling you the approach to solve these kind of problems, but obviously if in such scenario in which we can directly see that they will collide at some point, then we should not use this approach to waste the time. So we can directly conclude that D minimum would be 0. But in other type of questions like this, in which this distance is 40 and its speed is 30, and this distance is 30, its speed is 40, you can easily see that they would not collide at any point, and hence we can say that initially the distance between A and B would decrease, and after some time the distance between A and B would increase, which means that at the same instant of time the separation between A and B would be minimum. So we have to follow the same approach which we followed in the previous question, the second approach. So first of all we have to write VAB. So VAB is VA minus VB. This is VA minus VB, and VAB is equal to VA is 30 I cap minus VB is 40 J cap. Okay, so first of all we have to write down the relative velocity of A with respect to B. I am assuming that B is observer. You can also assume that A is observer. You can also find out VBA. Okay, it would not matter. Now you can see that this angle is 37 degree again, because this is 30 and this is 40, and tan theta is equals to 30 by 40, which is 3 by 4. So this angle tan theta is 30 by 40, which is 3 by 4, and it is theta is 37 degree. Now you can see that this vector VAB is pointing towards fourth quadrant, and it is making an angle of 53 degree with the x-axis. You can see that because its y component is equal to j cap and its x component is equal to I cap, and y component is 40 and x is 30. Okay, so this angle is 53, which means that if we draw this vector, then we can draw that VAB would be like that. Let us draw another diagram. In this diagram you can see that VAB would be like that. Okay, at an angle of 53 degree. This is 53 degree, and this is B at rest at this position, and A is moving with respect to B with the velocity of VAB. So you can see that if we draw a perpendicular like that from B to A, so this perpendicular represents the minimum distance between them, D minimum, and let's suppose that this point is M and this was A initially. So we can say that this angle is equal to alpha, and alpha is equal to 53 minus 37. Okay, and in this triangle this angle is 90, and AB, the value of AB, distance AB is equals to 50, because this is 40 and this is 30. So we can say that D minimum is equal to AB sine alpha. This is AB, and this component AM is AB cos alpha, and this is AB sin alpha. So D minimum is equal to AB, which is 50, and sin alpha is 53 minus 37. So D minimum is equal to 50 sin A minus B, sin A cos B minus cos A sin B. So sin A cos B minus cos A sin B. Okay, so this is the formula. So D minimum is equal to 50 into sin 53 is 4 by 5, and cos 37 is also 4 by 5, and cos 53 is 3 by 5, and sin 37 is also 3 by 5. So this is 16 minus 9, which is 7 by 25. So this is D minimum is 14 meters. So the minimum distance is 14 meters, and if we have to find out the time at which this minimum distance would occur, so to find out the time, we can say that if B is at rest, then the time in which A would reach from A to M would be the time for the minimum separation. So I can write down that this time would be the distance AM upon VAB magnitude. The distance traveled by A is AM, and the speed of A with respect to B is VAB. So AM, distance AM, let us use another page. So the distance AM is equals to 50 cos alpha, which is 50 into cos, this is 53 minus 37. So AM is equal to 50 cos A cos B plus sin A sin B. So cos A cos B plus sin A sin B, which is okay. So AM is equal to 50 cos 53. Cos 53 is 3 by 5. Cos 37 is 4 by 5. Plus again sin 53 is 4 by 5. Cos sin 37 is 3 by 5. So AM is equal to 50 by 25, and this is 24. So AM is equal to 48. So the time taken for the distance to be minimum is AM upon VAB. VAB is the magnitude. Now we can say that AM is 48 and VAB, the magnitude of velocity of A with respect to B, is this one. So VAB is equal to 50. So this is 50. So the time taken is 24 by 25 seconds. Okay. Now let us take another example. In this question, you can again see that this particle is moving with a constant velocity v1 and along x-axis, positive x-axis, and this one is moving with a constant velocity v2 along positive y-axis, and initially their perpendicular separation was d. So we have to find out the minimum separation between them. So first of all, let us write down v1 in vector form. So v1 in vector form will be equal to v1 I cap, and v2 in vector form will be equal to v2 j cap. Okay, so v12 is v1 minus v2, and v12 is v1 I cap minus v2 j cap, which means that if we have assumed that 2 is at rest at this position, then 1 is moving in the fourth quadrant, and therefore it would be moving like that. This is v12. Now this angle is, let's suppose, alpha, then tan alpha would be equal to this component x component upon y component of v12. So x component of v12 is v1 and its y component is v2. So v1 upon v2, this is tan alpha. Now if we have to find out the minimum separation between them, then this would be the minimum separation, d minimum. So this is given as d. So I can say that d minimum is equal to, let us use the same ink. So d minimum is equal to d sin alpha. This distance is d cos alpha and this is d sin alpha. Okay, so sin alpha, if tan alpha is equal to, this tan alpha is equal to v1 by v2, then sine alpha is equal to V1 by under root V1 square plus V2 square. So D minimum is equal to D into V1 upon under root of V1 square plus V2 square. This is the minimum separation between these two. And we have to find out the time also in which this minimum separation will occur. So you can again use the same method, that the time taken would be the time in which it would reach from O to M. So the time in which it would reach from O to M would be OM upon V12 magnitude. And OM is equal to D cos alpha. So this is D cos alpha upon V12 magnitude. So D is D and cos alpha is V2 upon under root V1 square plus V2 square. So D into V2 upon under root of V1 square plus V2 square multiplied by V12. So V12 magnitude is again under root V1 square plus V2 square. So this is under root of V1 square plus V2 square. So time would be equal to dV2 upon V1 square plus V2 square. This is the time taken by the particle to reach at the shortest distance with respect to 2. And the shortest distance is this one. This is D minimum is equal to dV1 upon under root V1 square plus V2 square. Now, this was the complete method and the best method I would recommend for the calculation of minimum separation between any two objects. But there is another method. In fact, there are two different methods. One of them is the method of maxima and minima, which is complicated, and other method is also a lengthier one. So we are not discussing, obviously, because I would not recommend those methods. So I am recommending this vector approach, which is the best and shortest approach, and it is very less prone to the calculation mistakes. So we would not use those approaches. But you can also try these problems by the maximum minima approach. Thank you.